All right. Can you guys hear me with this mic? Okay, perfect. Good morning. Thank you for joining us this snowy morning. We really appreciate you coming out and joining us for our first GenAI tutorial of the winter semester. It's my great pleasure to introduce Dr. James Boyko, Assistant Professor in Ecology and Evolutionary Biology here at U of M. And today he will be leading a session on using generative AI with literature review. So I'm going to let him take the stage with that. But really quickly before he starts his tutorial, I did want to highlight the last two sessions of this semester. So next session is using generative AI for visualization, and it's with Dr. Aitan Adar from the School of Information. And then we'll have one in March too around generative AI agents, and that will be led by our Midas postdoc fellows, Joseph and Nazarene. So please use this QR code to sign up or visit our website using sessions. We will also have two staff scientists. Hopefully they should be here, Nathan and Frank, throughout the session. So if you do have an issue while you're doing the hands-on tutorial, just please ask them or, James for any questions. And with that, I'm going to just hand off the mic and hope you guys have a really good tutorial.
Cool. Yeah, thanks for the intro. Yeah. Can everyone hear me okay? Good. Yeah, so I can go back to this slide. This is what we're going to be talking about. Thanks everyone for coming out. I appreciate you braving the snowy weather. So, I think we all realize why we're here. There's a lot of literature coming out very quickly, and it's, depending on your commitments and meetings and all of this, it's becoming very, very difficult, even without meetings, to keep up with everything that's coming out. And it's probably pretty natural to, with all of the generative AI that's been developed, to expect that there has been a lot of progress here. And indeed, there has. There's a lot of ways that we can use GenAI to expedite literature review. So I'm going to talk a little bit about what generative AI is very quickly, and then we're going to dive right into literature review. One thing to note is talks like these, where if I'm too focused on tools, can pretty rapidly become outdated. Like new technologies, new softwares are being developed all the time. The models are improving or changing. The goals of the companies developing these models are constantly shifting. So I do want to focus a bit more on the conceptual things, how we go through a literature review and how GenAI can assist. But I will be highlighting specific tools. I'm not trying to sell you on any of these particular tools. I'm not being paid by any of them. I'll highlight the one that the University of Michigan, has an enterprise account on. That's the one that I use most. We'll get to that towards the end. But I want to highlight a broad swath if I can. Okay. So we're going to start with what is GenAI. It's generative AI, sort of a prerequisite. So here's the AI overview of what GenAI is. It's a type of artificial intelligence that creates new original content like text, images, audio, code, and video by learning patterns from vast amounts of existing data rather than just analyzing it. This is a pretty stock standard definition, as you might expect from a GenAI derived definition. In a lot of ways, this is accurate, right? GenAI is something that takes tokens and then continues the set of tokens, and tokens can be all sorts of things. This is what tokens actually look like. This is how GenAI generally sees the world. This is a website called Tick Tokenizer, where you can add a message and then it will tokenize it. So each one of those symbols has a token that represents it. So what is represented by the number 4,827. And that's how the AI is seeing the world. When you are talking to ChatGPT or you're talking to something, what you're doing is just exchanging a string of tokens. You take a turn writing tokens, it takes a turn writing tokens. You take a turn writing tokens, it takes a turn writing tokens. If you're generating an image, those are also tokens. And so it takes the sequence of tokens, maybe I say the cow goes, and it wants to complete it. So it takes that sequence of tokens and then it guesses the next one. So maybe the highest probability is that the cow goes moo. There's a lot that goes into training a model, and it's very valuable, I think, to understand how these models are trained. to have an understanding of what's going on under the hood. Now, unfortunately, we don't have time, but I've given seminars in the past on how these LLMs actually work, and I recommend checking them out. Because there is something to be said about understanding and appreciating the tools that we're using when we're going to be probably more and more reliant on them because of sort of the incentives of academia being to publish quickly, learn literature very quickly. We need sort of to speed up. And so we're going to be more and more reliant on these tools, and understanding them at least a reasonable level, I think, is important. The general pipeline, essentially, is that you gather this massive data, you convert it into tokens, and then you pre-train the model. Pre-training the model is what creates this, essentially, probability distribution. And then post-training is what gives it a personality. So GPT it stands for Generative Pre-trained Transformer. The pre-trained is there. What gives it the assistant-like personality comes in the post-training. So you do all of this, you create your ChatGPT-like thing, and it culminates, I'm sure most of you are familiar with it, in something like this, right? This is ChatGPT, and if I say hello, it says, hello, how can I assist you today? Now, this isn't particularly impressive. We've had chatbots for a long time. They would struggle to like, the old 90s chatbots where you're using some sort of hidden Markov model to predict the next word. They would struggle to come up with this sentence. They would just look at the previous word and sort of predict what's next. So this is kind of impressive, but not super impressive. This wouldn't capture sort of, 30% of the market cap or whatever it is right now. But this is a little bit more impressive, So I ask ChatGPT, could you walk us through the chaos theory, but pretend you're explaining it to a raccoon who just stole your sandwich? And it can, it can explain all of this. It explains chaos theory. Very, very impressive that it can generate this level of text. Now, of course, what the model is seeing, it's not thinking through this necessarily. We're not going to get into if these things are thinking or not. But I don't think they are. The GenAI, what it sees is this sequence of tokens, right? It sees that the system message has started, you are a helpful assistant, the user has sent a message, it says this, and now it is your turn to respond, okay? So it sees just a sequence of tokens, and based off its massive amount of trained data, I mean, it is shockingly impressive how these things are able to have sort of emergent properties. But all it's seeing is this sequence of tokens and then spitting out the next set that it thinks is most helpful to the user. Oh, yeah. So, tokens can be all sorts of things. They can be images, they can be audio, they can be a sequence of DNA that is then folded into a 3D protein, they can be videos and words, all sorts of things. The tokens have now been sort of dolphin language and translated into English. So that's about as far as I want to go with GenAI. Hopefully you have a sort of sense about it. I do want to highlight just 3 things that are good to keep in mind specifically for literature review and kind of trusting GenAI and understanding what it's doing. So the first is that these models, and when I say GenAI, I really do predominantly mean these large language models like ChatGPT and Claude, Gemini, these sorts of things. One problem with giving a concrete definition of GenAI is that there's like probably a literal meaning that isn't what we use, and then there's sort of the public meaning. Anyway, so the first thing is that GenAI is probabilistic. It's not deterministic, so it's not going to always give you the same response. It is going to say what the most plausible next word is, and how that plausibility is defined is based off its pre-training data, but also what it has been tuned to be helpful, right? So that probability distribution is not just necessarily about the truth, but about pleasing the user at the end, right? It is supposed to be a helpful assistant, and helpful doesn't always necessarily mean absolute truth. And there's a probability over what it's going to say next. So that's the first thing. You're not always going to get the same response. The next thing that's important is that it has this attention mechanism. So the T in GPT stands for transformer. The transformer is sort of, it's a neural network architecture based off this attention mechanism, and it is sort of what has allowed us to have these big leaps. Most things now have transformers built in. Most sort of, most of the advances in neural nets, as far as I know, are based on these transformer architectures. And all that transformer architecture is doing is allowing communication between different pieces of your input, right? So here we have cow. You can think of the transformer as finding relationships between other parts of your input. So it can ask, one thing that it could try to find, are there any adjectives in front of me? And it says, yes, big and blue. So you're not just a cow, you're a big blue cow, right? So communication of words. And this is based off of sort of the input tokens, right? So the thing I want us to take away from this attention mechanism is that it can only see what's relevant, more or less, based off what you have inputted, right? Like if you had just said cow, it's not going to know it's a big blue cow. It needs those input context tokens. And so one of the useful things for literature review is that we want to give it tokens and context that is valuable, which is going to be our literature, that sort of thing, because it relies on that information if you want to have accurate outputs. The final piece is vector embedding. So one of the early steps in these LLMs is that they embed words based off semantic meaning. So we're going to talk about sort of the difference between keywords and semantic searches. So, essentially what this means is that when we input a word, we can sort of get a general sense of what the meaning is in some sort of high-dimensional space. So it knows that cow and goat are both farm animals. They occupy a particular range, a particular space in the embedding space. Red and blue are both colors. They're in sort of a distinct region. And this allows us to search things based off of not just keywords, but sort of the similarity of the word. So if I'm a phylogenetic comparative biologist, if I search phylogenetic comparative methods, a semantic search might also return phylogenetic comparative biology, even though biology wasn't in my original search, just because those two sets of words are going to be in a similar space. Okay, so that's all I want to say about GenAI. Are there any questions about it? Anything that... No? Okay. So if that's GenAI, what's literature review? So, take a moment, think about the sort of pipeline that you would go through for literature review. And this is how I wanted to couch this entire tutorial, is based off of the pipeline that we may go through if we were conducting a literature review. And the reason for that is I just don't want to go through a list of tools because those tools are going to be outdated. So let's think about the kinds of tools that would be used at different stages of literature review, because the methods I think that we use, the phases that we go through for a literature review, have remained relatively stable. So the 4 phases that we will go through are going to be defining a topic and research question. So this is kind of the brainstorming stage. You don't necessarily have a solid idea, but you have a general thing that you're interested in. Maybe you want to brainstorm and refine an idea. You want to find some initial literature. This is not necessarily about finding the set of papers that you're going to do a deep dive in. It's just sort of developing your idea. In phase 2, we're going to actually search for these sources and select which ones are most appropriate. Then we're going to analyze those sources. So this would be the stage where you're reading through everything, trying to figure out what the consensus of the field is for your particular research question. And then I'm going to very briefly touch on writing and text, writing text and citing sources. Part of academia is essentially you're a professional writer. So I'm not going to talk to you about professional writing. I think most people have a pretty good sense of it. So I broke down the AI tools into 4 categories. There's a lot of overlap between them. It's kind of hard to put them in distinct boxes, but I tried my best. So we have general tools. These are things like Claude and ChatGPT. They're trained on open web data, and they're sort of your first stop. They don't utilize anything. They now can access the internet and they can do a lot more, but back in the day, really, they were sort of segregated off, and they just sort of would base off their training data answer you. Now they can search the web, so it's a bit more flexible. Then there's academic search tools. These are things which can explicitly look through databases of scholarly papers. So something, not a lot of them access Google Scholar, but essentially these are things that have access to things like Google Scholar, this database of papers. We have local input tools. So these are things where you can upload your own sources and they will analyze those more directly, so not relying on something else. And then we have agentic tools, which I think is one of the most exciting developments in AI, not something that we hear a lot of because for whatever reason, the things that get hype are these like weird videos of generative AI. But agentic tools are really cool because they sort of split the task of conducting a literature search into a bunch of different separate AIs that you can imagine have personalities. And we'll get to the words. These are more all-encompassing tools, and we'll get to them towards the end of the talk. So we're also sort of going to go in order of these things from least all-in-one to most, like this thing can, if you wanted to, just like produce an entire lit review in sort of one query. So understanding these distinctions is going to make sure that you know the right tool for the job. And this is maybe a framework that you can think about as these tools are, as these softwares that I'm going to talk about are sunsetted, or they're no longer supported. You can always sort of think about this and think about where in the literature review phases you are and which kind of tools you could use. So maybe you'll be able to find your own. Oh yes, I forgot I was going to go through these. I kind of already talked to these, but let's just go through them one more time. So these are the tools that are from open sources. They're designed for general questions. Outputs may contain fake sources or hallucinations. Hallucinations are pretty well known by now, but it's essentially, we use the word hallucination to mean a falsehood. When ChatGPTs make something up, we call it a hallucination. I think that is probably an objectively incorrect definition. These ChatGPT, in a sense, and Gemini and Claude, they are always hallucinating, right? They don't know fact from fiction. They are always saying a probabilistic guess at a thing. We call a hallucination a response that we are not satisfied with, essentially, right? So all of these things are hallucinations. It's always hallucinating. It's just sometimes we like the hallucinations. And so the most popular examples are Gemini, ChatGPT, and Claude. And I've done, I'll also mention, Midas probably has these recorded somewhere. I've done deep dives on how to use these general tools for all sorts of different things. If you go to the Midas website, I'm sure they have them uploaded somewhere. Okay, so academic search tools, these draw from academic sources, peer-reviewed articles, which is going to be very important, or things on archive, so not always peer-reviewed, depends on the tool. And these are going to have that semantic searching and literature mapping capability. So I talked about semantic searching, where you are not searching explicit keywords, but looking for the sort of general meaning of your search and finding things that are similar, even if you didn't say the exact keyword. The local input tools, they upload specific documents, and they'll use something called retrieval augmented generation. So the G in ChatGPT stands for generative, right? These are generative tools. They generate based off that string of tokens. You can augment that generation based off a document that it retrieved that you uploaded. So you upload a PDF, it's going to augment how it generates the tokens based off that explicit paper that you uploaded. So these seem like very useful for lit review. And then these agentic tools, these are going to autonomously search and evaluate and synthesize information. They have steps. They report the intermediate findings back to like the head agent, and then it sends out more agents to do different searches based off what it fed in. It sort of has this loop. I mean, these are really, really cool tools. Okay. Let's get into it, because I've already used 20 minutes. So we're going to go through these 4 phases, and I'm going to talk a little bit about how we would normally go about it, maybe, and how we can augment things with AI. So we're going to subdivide phase 1 into 3 sections. We're going to talk about brainstorming your topic, exploring the academic literature, so just sort of getting a general sense, and then developing your research questions. So how would we sort of standardly go about finding a topic? Well, I mean, you would probably search Google, Wikipedia, maybe depending on what kind of work you're doing. Maybe you're browsing the newspaper, creating sort of concept maps in your head so that you can find key terms. the way that you would use AI is just to ask a general AI like ChatGPT about the topic, gauge the scope and variety of the question, and then one thing that's kind of useful is not just to rely on a single model, but try to ask several different models. All right, so our goal here is just ideation, broad exploration. So we have Gemini, ChatGPT. Maybe this is obvious, but I want to say it. Make sure that you're checking for internet connectivity. These things, they're going to the cloud and they're coming back with their answers. You can use offline models. I'm not going to talk about too much about running local models. They're pretty heavy. Like, it takes a lot of compute to run a model locally. And at the moment, they're behind the state of the art, probably about like 6 months behind state of the art, which is pretty impressive considering how good these big companies are, their models. And one thing I always recommend, and one thing that I do often when I talk to one of these models, ChatGPT or Gemini, I will ask the same thing, if it's important, to multiple models. Now, it's not foolproof, obviously, or foolproof. They can both give you wrong answers, but it is better to have some consistency. If you're just relying on the models, obviously, there's future steps where you would really dig into the literature. Okay, so ideation. Maybe I want to come up with a project for climate change, and so I go to ChatGPT and I type in, tell me about climate change. And then it'll spit out a long response. This is what climate change is. The dominant causes are this. It's not the best way, I would say, to find an effective query for developing a research question. And so for these general AI tools, what I want to talk to you a bit about is prompting. So the practice of prompt engineering is how you design your question and your query to the ChatGPT or to Gemini to get the most effective response. And I mean, this is like a real area of research, is how to effectively prompt these things. And this area of research has also changed the way that the models are sort of rolled out to the user. So sometimes the prompting research that has been done changes the way the models are trained or changes the system message in the model. So by the time that you do it, sometimes these prompts are already built in a sense. But it's still important to think about how you are talking to the model. And so we're going to just get sort of a baseline foundational lesson on that. So a prompt is essentially an instruction or cue that you give to the generative AI model to guide it in what it generates. So when you provide the prompt, the AI model uses what it has learned during its training to generate the response, right? So this is that initial sequence of tokens that it will use to generate the rest of the sequence of tokens. And it's very important that you have one that matches your goals. And these are like old AI generated images, which I thought were cooler than the really new and high quality ones that you can barely tell now are fakes. I prefer these old ones. So the role of the prompt is it sets sort of the initial context. If you're just using one of these general AI models, it's not going to have other context than its training data and what you have talked to it, and the system message, but we won't get into all that. So the more specific the prompt, the more direction the AI has. So this is my foundational prompting advice if you're going to be talking and using these general AI tools. I'll give you, just because we don't have time, I'm not going to go into some of the more advanced topics within it, but these are sort of the baseline. You should always be thinking about this kind of thing if you are talking to these general AI models. So the first thing is that you want to be specific. If you give it a vague prompt, you will get a vague result. When I ask it to tell me about climate change, it doesn't give me a very specific response because I didn't even tell it that I was looking for a research question. It doesn't know that I'm an academic trying to develop some sort of research question. I'm just tell me about climate change. So a bad prompt would be give me information about artificial intelligence, and then a good prompt would be more specific. Maybe I want the key advantages and potential ethical concerns for using deep learning for medical diagnostics, right? So the more specific you are, the more you can set that string of tokens to give you the thing that it wants. In that same vein, you want to make sure that you're using keywords that are appropriate within your context, right? So maybe you want to use words like carbon pricing policies, climate change mitigation, economic. These are all words and tokens that the model will pick up on and then generate a response that is more appropriate. Again, this is sort of obvious, but really, really important. Another really important thing is that you can give it examples. Again, this is what people will do in real research projects that use these things. They will give examples for the exact output that you want. So maybe you say, make a chart to help me understand the data, or make a list. It's more effective if you give it an excerpt of the CSV, and now it's going to know, once you want a CSV, you want sort of a continuation of this exact output. You can say, I want it as a JSON, all sorts of outputs, and then that output will be mapped exactly to what you are specifying, more or less. Now, of course, they're probabilistic, so it's not always the case, but examples are a really good way to get it working. This is a bit of a funny one, but actually, again, pretty important. So the way the voice of your prompt has a huge input, sort of the tone of your message. These things are trained on tons of data from social media to probably academic sources. We don't know what the training data is, right? If you ask a question professionally, it will respond professionally. The set of tokens that it has been trained on will move towards that professional set. If you ask a question playfully or casually, it might rely more on its social media knowledge. We don't know exactly the inner workings, but there is some work that suggests that yes, the way that you ask the question, proper capitalization, proper punctuation, does influence the quality of results. This was a big thing when they first came out, sort of role playing. It is good to give the model a role, say that you are an academic scientist. Back when these were first coming out, people would be like, oh, you are a highly innovative genius, out-of-the-box thinking mathematician with the IQ of Einstein and Newton combined. And they would expect like smarter responses, but it was just sort of like more arrogant responses is what they got. I never really liked that prompt, that sort of philosophy of just like, oh, you are really smart, be smart. And it's just like, the role is important, like say that you are a mathematician, you are a research scientist, but you don't need to like really ham it up. So set a role, ask the chatbot to take on a specific role, that can be useful. We'll talk about, when we towards the end, we'll talk about writing, and one thing that's really useful is like act as a critic, act as a harsh reviewer, that kind of thing, and you can get feedback on your writing that way. Another really important thing is chaining prompts together. These models, this was more true in the early stages because now they sort of do this internally anyway. But often, if you break a prompt into smaller steps, you can get a higher quality response. So you are way more capable of thinking things through in a piecewise fashion than these models are. They sort of will run off based off their string of tokens, and if you are chaining your tokens together, you are able sort of to insert your own thoughts in the thought process of the model and generate better responses that way. So here's a draft of my abstract, identify instances of the passive voice, are there any phrases or words that are awkwardly? So you just sort of go step by step rather than asking it to do all of this at once. Models are a lot better now. You could probably get away with doing everything all at once, but best practice would be to split it up. Okay, so that's all of the sort of foundational prompting advice. In some of the previous Midas seminars, I've gone through more advanced prompting advice, but here I'm just gonna, I just gave you a list of links. Chain of thought prompting was like a huge thing when that was sort of researched for the first time. And it is, pretty fundamental to these thinking models that we have now. Again, we're not gonna get too into the weeds on the different types of these general AIs that we deal with. But I recommend checking this out if you're interested in more advanced prompting. For our purposes today, I found this. This is a nice heuristic for setting up a prompt. So this is the proper framework. If you're sort of new to thinking about how to prompt the model and you want to just get like a good baseline, this is a good way to approach it. Think about your persona. Actually, I think my slides will go through these one by one. So you want to think about the persona. What is the role the model should take? So are you a climate scientist? Are you a critic? Are you a reviewer? So maybe for my climate science prompt where I'm trying to get some idea of what I'm going to do, I say, take the role of a climate scientist. You want to say your request very clearly. What's the task that you are doing? You have to write a literature review paper about climate change or some general topic. What's the methodology? So just 5 possible research directions, each with a short description. So how is it going to operate? You want that to be as specific as possible. What is the presentation? What's the style, the tone, or what is the output going to look like? How are you going to present the results? So maybe present it as a list. Oh, I didn't go through examples. Well, we'll talk about that in a little bit. So if you just take those ones, the other ones are up to you. They come in a little bit later. My prompt might look like this. You are a climate scientist. You have to write a literature review paper about climate change. So just 5 possible research directions, each with a short description explaining why the topic is relevant and what kind of research questions could be explored. Present all of these as a list. And that's what it will do. It will go through climate sensitivity and feedback mechanisms, regional climate change, and extreme events. Now, this is not really where your idea should come from, right? Like it's a bit irresponsible to think that ChatGPT is going to produce a research question that is of high quality that you can then use. However, what this does give you is some keywords. So if you're new to a field, and that's what, one of my favorite uses of these things is learning about a field that I'm not super familiar with and finding a set of keywords, right? You don't need this if this is your main field. If you're a climate scientist, you don't need to ask ChatGPT to find these words. However, if you're not a climate scientist, then there are some nice keywords that you can find here. The cryosphere albedo interactions. I didn't know that was a thing. I have like a vague idea of what that might mean, but I didn't know that was like a real thing that you would put into a keyword. And apparently I don't have something about examples and refinement, so I'll just talk about it quickly. So I talked about giving an example earlier. Refinement is a really important part of this. So you want to iterate and feed and improve your results. So maybe the first time you gave the prompt, it wasn't satisfactory. There's 2 ways to go about it. Either you can ask again in the exact same chat, and then it will have that context of the previous chat and continue the string of tokens that way, or you just start a new chat, start from a fresh slate, and then you just have a better sort of initial prompt. And you'll get different results doing either. But refinement is an important step. Okay, so we've brainstormed a topic, maybe we have sort of refined our ideas, we have started finding some keywords that might be relevant. Let's go on to exploring the academic literature. So in the previous step, we generated a bunch of keywords, and now we want to map these new ideas and these keywords that we're interested in to existing academic literature. The goals here are going to be to try to gain some sort of overview of the field. We want to identify any existing literature reviews that maybe we want to do an in-depth read on, right? So a lit review that already exists is one useful thing. It saves you a lot of trouble of finding making your own literature review, essentially. Another goal might be to find research gaps, right? Maybe you have this idea, you think it's a research gap, but you have to sort of verify it. And the best way to do that is through a literature review. And then you want to move from those open web sources, which would essentially those ChatGPT, which are trained on open web, to more scholarly sources. We want to start really just focusing in, rather than this broad swath of training data that we don't know where it's coming from. Now we want to start focusing in on real academic scholarly sources. Question or just no? Okay. So standard versus AI practice. So the standard practice is, you would do some sort of topic level search in a big database. So Web of Science, Google Scholar, whatever it is. Scan for review articles, maybe analyze the titles, abstracts, and keywords manually. With AI, we're going to use specialized tools. We are going to want the AI to summarize the findings, mainly from titles and abstracts. It's going to be getting the information. Where it gets the information will vary depending on which tool you're using, and we'll get more and more into that. And then maybe we want to visualize some sort of consensus or disagreements in the field. So this is usually a good starting point, right? You start here often, at least I do, when I'm looking for new research, or when I'm trying to develop a research question, I'll start with Google Scholar and I'll try to search for something. Now, some of you, this is a new development within the last month or two. Google Scholar now has this Scholar Labs thing. So it's an AI-powered search. If you don't see that link there, they have it up here. You might have noticed it next to your library, your profile. They have this Labs thing. If you click Labs, you'll be taken to this page. And this will allow you to start doing semantic searches, right? So with classic Google Scholar, it is based off of keywords. They might have some semantic searches in there. But now you are going to ask questions essentially in basic English, right? Has anyone used a molecule footprinting to examine transcription factor binding in human cells? Like that's just like an English sentence that you would ask. It's not necessarily how you would do a Google search or how you would do a Google Scholar search. So this is what, when the blog came out, they said this about it. It's powered by AI to act as an advanced research tool. It analyzes your question, identifies key topics, aspects, and relationships, then searches all of them on Scholar. After evaluating the results, it identifies papers that answers your overall research question, examining how each paper addresses it. Now, I haven't seen that capability quite yet, like the interaction between the papers, but this is a new tool. It's still sort of in beta. And one thing to keep in mind with Google is that they sunset a ton of their software. This might not exist next week. You know, they just might stop supporting it, or they might have a different version. They might rename it. But this will give a good entry point for like on a familiar platform that will allow you to sort of start exploring how we can search for papers in a different way. So I'm a phylogenetic comparative biologist. I'm an evolutionary biologist. And my sort of subdiscipline is phylogenetic comparative methods. Maybe last semester, I was teaching last semester, right? So I fell behind on a lot of things, and one of the things I fell behind was literature review. So maybe I want to figure out what are the latest developments in my field. And I'll just ask, what are the latest developments in phylogenetic comparative methods? So it'll go through and it'll produce something that looks like this. It's going to evaluate a bunch of sources. It's going to search Google Scholar. It's going to rank them. At the very top is my question. It is going through and it's going to look through a bunch of different results. It's not going to share with us what it's searching, how open each of these things are, how open each of these tools are, and how it goes about doing these searches varies. So we just know it's going to be evaluating 26, 50, 100 results. And one thing to notice, so some of the results there are on the right. One thing to notice is that all of the papers that it has suggested, or the books that it has suggested, are from pretty recent, from 2022, 2023, 2025. Those are recent developments. I didn't have to specify a filter that it had to be at least 2022. You could specify that. You could say only 2025 onwards, but just sort of, it understood by latest developments, I meant very recent research without specifically specifying a keyword. Obviously, the other thing that it gives you is these nice summaries. So normally, if we were to do a Google Scholar search, we might be presented with an abstract, or you would click into the paper and you would read the abstract. Here, we're given a very quick 2-point summary of each of the different papers. So very useful and can save a lot of time for skimming through these abstracts. Because abstracts are often very technical. Even in your own field, they can be kind of hard to skim through and understand fully. If you have something that's a little bit digested in basic English, maybe you can use that. But these are just using what's available, which is going to be the title and the abstract, or these summaries. So the nice thing is that you can ask these queries in plain English, and you can get a quick summary of each paper. If you are this is more of an exercise for you to do on your own, but maybe compare the technicality, like how technical the summaries are versus the abstracts. We don't know how it's summarizing. We don't know what the prompt is that Google gives it to digest this information. So it can be good. I find it's like a nice mix between the technical and basic plain English. The other thing, even though that Google said in the blog post that was coming, there's no information about how the papers relate to one another. It is just sort of a ranked list about appropriate things, like based on my query. So there's no joint summary at the end. There's no consensus. There's no identification of gaps or themes, which might be one of our goals. And so, I think about it so far. It might develop or it might be sunset. We don't know. It's just sort of a standard Scholar search with this AI summary attached. But that's useful, right? That's already pretty useful. Any questions so far? Yeah. The slides are online. I think they should be uploaded already. I had trouble uploading them, so I had Kelly just do it recently. Yeah. Okay, so now let's take that literature and try to develop our research question a little bit more. It's sort of going to be a cartoonish development of the research question in a sense, where I'm going to, this isn't going to be the best practice necessarily, but if you were like very reliant on AI, this might be what you could do. So this is Andre the Giant. For those who don't know, it's because we're standing on the shoulders of giants when you're developing a research question, right? You're using academic literature. I won't explain all of my references, but this one, I figured if there's like a big man in a leotard, I had to explain why he's there. Okay, so you've now explored a general topic and you have this academic literature. You probably have identified what is known and what is missing. And now you want to figure out what you want to add to the field. Or maybe you want to use AI to help you identify what is known and what is missing. And maybe you want to now formulate a specific and researchable question. So let's use the way that we already know, right? We'll go into more specific tools that can do this in a better way, but let's just keep it simple right now. Let's go take our AI summary, right? We're going to look at all of these results, and we're just going to copy and paste them into ChatGPT. And then we're going to use our prompting knowledge to develop a prompt that gives it a role, and then I tell it what to do based on the sources below, identify the current gaps in phylogenetic comparative methods, and formulate 3 specific and researchable questions. You can make this prompt a little bit better. Your mileage may vary depending on how you prompt it, but this is a very simple, and this isn't how I would develop a research question, but it is a simple way that we already know how to do it. We're pretty familiar with it. And you'd get this, right? So from these gaps, from the context that I gave it, now it's not relying on that opaque knowledge that it has learned through the open web, through its training data. It is now taking that information, that context that I gave it, right? It is making the connections between all of that using those transformer architecture style neural nets. And it is developing that next set of tokens based off what I gave it, right? So now I have given it explicit context. Its answer is going to be based off what I gave it, right? It might use some of its more opaque knowledge to develop it, but really the way, especially now how they're trained, it's really going to give you a response that is specific to what you've given it. So it's going to base it off of those AI summaries. So I'm feeding AI with AI, so take that for what you will. And maybe I don't like that first response. It's a little bit vague. Maybe I wanted to force it to think through the question and then arrive. So I'm going to iterate. This isn't the most appropriate for my work necessarily, but maybe in some other aspects of science and research it would be. So maybe you want to say who, what, where, when, why, like start broad and get down to the specific, break down the set of questions. And this is valuable to do, to force it to think through things, because the way that it arrives at an answer is going to depend on the set of tokens it sees. I didn't put the example in this talk, but if you were to ask a simple math question, so say you do 2 + 2 = something, right? And you ask ChatGPT, what's 2 + 2? And you can get it to respond with a single token. So what is 2 + 2? Respond with 1 token, so just 1 digit, and it'll say 4, right? If you give it a more complex math problem, and you say, what is the square root of 33 plus 10 divided by 3, some sort of math problem, and then you say, respond with 1 token, it will get the answer wrong most of the time. If you ask it to just answer normally, it will follow the string of tokens. They've been sort of taught how to think through a problem. It'll do the math, and it'll arrive at the correct answer, because it's using tokens previously to generate the next response. So if you can get it to think through a question, it'll give you a better result, at least in the math domain. It would have been a good example. Maybe there are, if you look up the foundational model talk I gave, there's a section about that. Okay, so this is the prompt I'm going to do to iterate and try to force it to think through. So formulate a single question, think about the foundational, the core elements, the who, what, where, when, why, start broad and then narrow it down, and then break the question into exactly what you will study. Okay, so it's just iterating through the prompt, trying to really get it to synthesize the information in a way that I would find satisfactory. This is what it gives me. It does go through everything. It goes through the why, it goes through the who, the what, the where, when. And then it goes general, and then it narrows down, and it ends up with this kind of question. This study will compare the standard PCM to gene tree aware, we don't need to talk about that. Is this any good? Well, I mean, what it essentially has suggested after all of this was to compare all of the new methods from those papers, but this time do it in a single paper. It's not the best question. But it can be, it can still be useful to go through this practice. Okay. So we're at 9:45, so it's actually a good time to pause. So this is now the sort of more active part. This is your first turn to just start exploring these tools, right? So I put the persona, the proper framework up there. And so all I want you to do, don't take it like this is the be-all, end-all, but just start by generating some ideas from Claude or Gemini. Try the Scholar Labs to find papers, feed it back, and maybe just notice some differences. If you want to compare the AI summaries to the abstracts, this would be a good chance. Talk to the people around you, see how it differs, and then maybe report back on our findings, and we can discuss how we think this model works. What do we notice about it, right? Don't judge it as maybe good or bad or whatever, but just like, what do you notice about this sort of pipeline? Okay, so we'll take 10 minutes to 9:55, and then we can have a little 5-minute discussion. Yeah?
I just have a quick question.
Sure.
So UMGPT versus ChatGPT, I understand that there's differences in terms of security and that kind of thing, but are there differences in terms of what data? Like
Yeah.
Which one should we use, can we use, which one?
Well, so I mean, the reason you would use UMGPT is because has a tighter control of the data, right? They're not sharing it, they're not using it for training. The model itself is worse. It is an older version of ChatGPT. I don't know how old. We don't know when the training data was cut off. But yeah, it will give you. It is an outdated version of the model. It might be constrained in other ways. We don't. It's not super open. Yeah, it's a good question.
Just a quick follow-up.
Yeah.
So how does it train if it's not using our data to feed into?
How does
UMGPT?
So UMGPT takes the ChatGPT model, they freeze the weights. So the neural net has a bunch of weights and biases that it uses to generate that next set of tokens. Takes that, and then they put that into their own model. So it is just like a snapshot of one of the older ChatGPTs. I don't know, they might fine-tune it in particular ways and say, never do this, don't do that, or like might dissuade it from giving particular responses, which they can do through reinforcement learning. But there's a bunch of techniques, and I don't know which way they use it. But it's essentially just a snapshot of ChatGPT, and then they don't train it. So ChatGPT has already been trained, right? It's been trained on the entire internet. It's been trained potentially on what users have input in earlier generations. It's been trained in probably very nefarious ways as well. These are tech companies. I don't necessarily have good things to say about them, right? So we don't know the training data, but is not training the models. Yeah, those are really big endeavors that take lots of resources, water, electricity, and one can question whether they're really going to solve global warming. Okay, so yeah, off you pop. Oh, more questions, yes?
Are the paid versions of these models going to be significantly better?
It's a great question. It's tough. So I think you can get a lot of mileage with what is available. So Gemini, you get a ton of free queries. The most advanced models generally are not worth it. It's just more if you want to use the state-of-the-art model, you will get more queries in the paid versions. So you will run out of chances to prompt it. So GPT 5.2, I think, or 5.1, is the latest model for ChatGPT. You will have maybe something like 10 queries that you get for free, and then you have to go to one of the lower tier models. It is significantly better by sort of all benchmarks. Benchmarks themselves, so benchmarks are things that they will use to test the model. So like how good is its math ability, how good is its ability to find a needle in a haystack. So like you give it a long text and it's like who was the murderer, and it has to find like little pieces of information. So generally like they're better on benchmarks a lot. Anecdotally, they seem to work a lot better. But you can get pretty far. And I mean, just like a few months ago, the state of the art was now the free model that you get downgraded to, So It's up to you if you want to pay for some of the additional features. I think you can get a lot of mileage out of the free ones. There's a few things that I paid for mainly to prepare for this tutorial because I'm going to talk about NotebookLM eventually. I paid for the Google Pro subscription just to make sure that, you know, you can get most of the mileage with the free stuff most of the time. If you're running into those limits, consider it, right? And then has a couple free of things available, right? So we have GPT. That's going to be a higher quality model probably than the free one, lower quality than the state of the art, but it's somewhere in the middle. We have a subscription to Consensus. Maybe use that instead of subscribing to Perplexity or something. Yeah.
Kind of related to that, there's also like for ChatGPT, there's instant versus like thinking. And also I think Gemini has like something
Yep.
similar. So like, can you advise on which one to choose?
Yeah, so that's another good point. So thinking versus the sort of instant fast response. So the thinking paradigm began, well, before DeepSeek, but DeepSeek was the first model that was an open source model that approached like ChatGPT levels. And they did it by using this thinking paradigm. So rather than answering your query right away, the model goes through this stepwise process where it will evaluate the query and essentially just talks to itself. It just generates a lot more and more context. So remember the math thing where it's like its final answer is going to be based off of all that came before it, right? It uses all of that context. So if it talks to itself, it generally comes up with a more high precision and accurate answer. It takes longer, it takes more tokens, but it is generally better. Advice for using it is if you need like a really high quality response and you only have sort of one shot at it, go for the thinking models. If you just want fast responses and it's like a super simple query and you're using it instead of Google, you can probably just use the quick response type of thing. Yeah, but that was a really big paradigm shift. So yeah, thanks for bringing it up. Any other questions?
So, what's your thought about using the deep research feature when you say
Yeah, well,
this task?
we will get to some of those features a bit later. We'll go more in depth on that. This is like meant to be bare bones. But yeah, they're pretty good. Yeah, those agentic based searches. I don't think I'll talk about specifically about deep research, so I can talk a bit about it now. So there's another option on ChatGPT and Gemini where you can do a deep research query, and these are going to be those agentic-based models where they will search something, evaluate the response, then do another search based off what it found, and then do another search, and sort of go step by step evaluating some research question, and then bring it all together in a report. These are the ones that are built into those general AI models. So this is when I say there's like a lot of blur, this is one of the reasons. So they will produce a report. We're going to talk about a couple of systems that are quite similar. But yeah, they're pretty good, and they will source their findings, right? They will say, at least they will give you, they will tell you where they think they found that information. Whether or not it's accurate, you would have to go check. But yeah, we'll talk more about that in a little bit. Not those exact tools, but similar. Any other questions?
Sort of,
Yeah.
so the cloud version we're using on through UMGP, that doesn't train our data.
No, I don't. I'm pretty sure ITS said that it's like completely secure. I think there's maybe special setups if you're doing like medical information and you make sure it's get de-identified and stuff. But yeah, our data is much more secure on UMGPT. Yeah. Sorry, what was that? The last part? Yeah. Uh-huh. Yeah. So for the next step, yeah, you would use ChatGPT or Claude or Gemini. I don't think that some of the agentic things that are built into ChatGPT. So like ChatGPT and Gemini have access to the web. I don't think that they go to Scholar and search papers. That's like the nice thing about the Scholar Labs is that it has access to the Google Scholar database, which is probably massive, and who knows how Google collects that, but it is, I find it to be the most up to date. It has bioarchive things like the same day they're posted. It is really, really good. I don't think ChatGPT has access to it because Google usually isn't so forthcoming with that. I know there's like ways around to like query it, but they don't have like an API or anything as far as I know. So ChatGPT can't query Google Scholar. It does query, I don't know what it queries, they don't say, but yeah. Cool. I'm gonna grab a drink really quick, but I'll be, oh, yeah. Yeah, yeah.
So presumably Scholar Labs can't hallucinate or won't hallucinate?
No.
One of the problems is you get hallucinations, you have to check them all.
Yeah.
How do you know when there's something that's not going to hallucinate on references?
Well, it won't hallucinate on references, right? It will be summarizing the exact document that it says it's summarizing.
Okay, that's what I meant.
Yeah.
Hallucinate references.
Yeah, so it won't hallucinate reference. It's using Google Scholar, it's getting the exact references that on Scholar, and then it's summarizing that information. So it is directly, like that summary is directly linked to that paper. There's no way for it to hallucinate that. The sourcing of stuff, so we're gonna talk about models that do this agentic-based thing. They search for a source, they read the source, and then they say, like, this is what the source said. That's not gonna hallucinate, but the source might not actually be saying what it says, type of thing. So there's still plenty of potential for hallucination to occur. For the specific Scholar Labs, that's gonna be like one-to-one mapping that summary of that paper. Is that summary a hallucination? That's possible. Okay. That could still happen.
But Gemini or ChatGPT can hallucinate references.
Oh yeah. I mean, like, yeah. If it sounds like a good reference, it'll produce it and it'll be like, yeah, this is what the reference is, and it'll sound realistic. It'll be the right kind of people doing the right study at the right time, right? It's better about it than it used to be, but yeah, it'll still hallucinate references. Okay, I should have brought a water bottle, but I didn't, so I'm gonna grab a drink and I'll be right back. Then we can discuss the findings. Any thoughts? because I only have an hour, we don't have too much time. I might skip the other activity just so I can make sure we get through all of the resources. But anything anyone wants to share? I know we had like a pretty long discussion just now, so I feel satisfied. Cool. So in that case, let's move on to phase 2 of the literature review. So this is going to be searching and selecting sources. We're going to start integrating some, well, fancier models and maybe, more interesting potentially, things that maybe you've heard of but haven't used quite yet. So there's going to be 2 pieces of this. The first one I'll go through kind of quickly because I think you'll get it pretty fast. And the second one we'll spend a little bit more time on. So find keyword searching and finding additional sources. So if we wanted to find and do like an in-depth literature review, a systematic review, we would create these Boolean strings of keywords. It's like, I want phylogenetic in it, I want comparative method, I don't want cancer, because that comes up sometimes when you put comparative in it. So you would create this like long string that will be very specific to the topic you're researching, and it's very reproducible, so you'll always find the same papers. If you're trying to do a meta-analysis or some sort of systematic review, that's where this starts, right? So maybe my question is, how effective are telehealth interventions for managing type 2 diabetes in adults? So the string I might come up with is telehealth and type 2 diabetes and adults. These are the things that I want in my keyword search. The problem with this is that it's one term per concept, right? There's no synonyms, there's no spelling variants, there's no controlled vocabulary. I just learned about this mesh thing. And then it's low recall. So you're going to miss a lot of relevant studies because you haven't included all the relevant terms. The things that you might want to include just, are telemedicine, remote care, virtual visits, T2DM. I mean, this is essentially like the Zoom help type 2 diabetes patients in adults, right? So there's a bunch of different terms. Now, what you can use for GenAI is, so these are, again, those big general tools that we've been talking about, is that you can have it assess your query, your initial query, and then have it generate some additional things to consider for the question. So my recommendation is don't ask it to generate the query from scratch. You can do all that research, you have this research question, figure out the sort of base query that you want, and then you can have it critique it. So what you could go is you say, here's my search string for PubMed. I specify PubMed so that I can get a search string that is appropriate for it. And this is what I said, telehealth and type 2 diabetes and adults. So please suggest any missing synonyms or relevant terms, flag any technical terms that I might have overlooked, and then don't remove any of my content, just expand it. And so it's like, great, here's your string, here's a bunch of keywords and synonyms that I've thought about, here's some relevant mesh terms, and then here's the example that it gives you. And it's like this really long string that would have taken ages to come up with. It might be a bit overkill, but it'll get the job done, right? Like that'll be a very specific search. It'll take a list of maybe hundreds of papers or thousands of papers, get it down to like 100 or so, and it'll be very specific to the thing that I want. So this is a nice way to find, to just sort of take that search string to the next level and really help you hone in on particular papers if you want to stick with sort of a traditional database, which you may want to. And just to highlight this, we talked about it a little bit, but these ChatGPT and Gemini, they're really not great for searching for papers, right? Like there's lack of reproducibility. We don't know how they're doing the search. It's not deterministic. They don't access metadata. As far as we know, who knows like how those web searches work? It's not super open. But as far as we know, they're not accessing metadata. And they don't have, how they're doing the search algorithms is not clear. So you don't want to ask it for those peer-reviewed articles directly. You want to have it develop a string and then go into the search itself. Okay. So the next stage of searching and selecting these sources is going to be finding additional sources. And I'm going to break this up into 3 chunks. The first is literature mapping. This is a bit more of a traditional approach. It does incorporate some AI. Then we're going to do semantic searching. So this, you've done a little bit of that with the Google Scholar Labs, but this is where you don't need exact keywords to do the literature search. It's going to sort of understand the gist of what you're searching for and sort of look in that vector space and figure out what you mean. And then we're going to talk about agent-based searching, which is really cool. Okay, so citation-based searching. This is sometimes called snowballing, where you find some sort of highly relevant seed article. So like this is the thing that maybe inspired you to look into a particular research question. This is like that main central paper that you found really interesting, and you want to see who has cited it, who did they cite, right? Backward chain it, and then you want to see who has been citing them, right? So you sort of get an idea of the scholarly conversation and the lineage of ideas. And this is, again, very difficult to do manually, right? Especially, with Google Scholar, we do have some tools, right? You can click on the cited by and figure out who has cited them. You can look at their references and see who they cited, but it's hard to sort of go through that in a sort of systematic way where you get really a sense of which papers are most important, which are least important. So for our example, I'm going to use this paper from Biology Letters. It's a really interesting study by Melissa Bateson, who is an ecologist, or at least evolutionary biologist and ecologist, and she studied cues of being watched, enhanced cooperation in a real social setting. The study breaks down to this figure, right? So they had this pot of money that everyone would contribute so that they could buy milk for their tea. And they wanted to see if they could like sort of prime social behaviors in this. So somewhere non-obvious, but in the room, like in that break room, they would put an image of flowers or they would put an image of eyes. And the idea is like if you're being watched by eyes, you're more likely to pay into the communal pot, right? It's a you don't have to pay into it, but like if you pay into it, you're sort of contributing to the community. And so what they found was the liters of milk, or the amount that they paid is on the x-axis, weirdly. And so you pay more if you're further to the right, and then as time goes by, they did many replicates. They did this sort of paired study design. So what you see is that generally people pay more when they have those eyes somewhere in the background. I've tried this in the biological sciences building on the second floor. We put a photo, like we had eyes, like these monster eyes above the sink, and it's because people weren't washing their dishes. And I don't know, Mia, did it work? Oh, I guess you're on the third floor, yeah. Darn, yeah. Well, it seemed like it worked. Anecdotal evidence that it might have worked. Okay, so that's my seed study. I find it a very interesting topic. I'm going to use that as my seed paper. And then I'm going to map the connections between authors, people citing them. And for this, we're going to use Research Rabbit, which maybe some of you have heard about. We're going to try to identify clusters of related papers and sort of find other seminal papers. So this is the Research Rabbit website. I'll have links at the very end of this tutorial for all of the tools that we've talked about. And you can add a bunch of papers that you know and love. So here's cues of being watched. I can go find that. You can connect to Zotero. There's a lot of ways that you can upload a paper. So I search for it. I find this paper. I'm going to add it to my collection. And maybe I'll sort of go through and I'll add a few other papers from that search that seemed relevant. So now I have this collection of 4 or so papers. And I can see it there. And then I want to explore that set of tools. So I can look at the similar work as to what was published there. I can look at earlier work and later work, so things that are citing these papers or have been cited by these papers. And I can explore the authors, look for suggested authors. There's a lot of ways to build that network between the papers and really, in a very formal way, not just in terms of ideas, but in terms of, literal citations. Who is citing who has connections to who is like collaborating. You can go through and very formally find the connections between papers. And sort of the crown jewel of this whole thing is maybe you want to just see what's earlier, you want to find the earlier work, and you get this sort of map. So here you can see who is citing who, you can see how influential a paper is, I think just based off the number of citations, based off the size of the ball, and you can visualize the connections between all of these different papers and maybe go through in a way that is a lot friendlier than just looking at the reference section of an actual paper. So the blue dots are ones that are not in my collection, and the green ones are. And if you were to click one of these papers, one that's not in my collection, I could add it to my collection. I can see I can see an abstract for the paper explicitly. There's no like AI summary. At least when I first made these slides, there probably is an option now to integrate AI. There's always an option to integrate AI. And so you can get this summary through the abstract and see if it's relevant and then add it to your collection if it is. There's also this timeline feature. So I had specifically said I want earlier works than this Bateson paper. Those are the other papers in my collection on the left. And then you can see that it's all the papers that the Bateson was influenced by or cited. Okay, so that's literature mapping. Again, we're trying to find like new papers that we want to add to our literature review that we think are relevant to our research question. The next thing that we're going to do is semantic searching, and this is going to use that vector embedding thing that I talked about, where like the semantic meaning is what's more important than the exact keywords. I have a picture of spam up here because a similar concept is used to identify spam versus ham email. So a ham email is one that you want. Spam is obviously a phishing attack or something, things that are that should be filtered out. And they use this sort of vector embedding. Rather than keywords or something like that, they can figure out what kind of emails generally are spam and what are not. And they use vector embedding to do that. So you're not going to be finding papers that use the exact same terminology necessarily. You're not going to be using keywords. You're just going to be sort of speaking in plain English and getting your results that way. So the tool that I chose this time was Elicit. Like I said, there's a lot of overlap these days with the different tools and what they can do. So Elicit can do more than just find papers, but for this purpose, we'll use it to find some papers. So here's the find papers section, and then I'm just going to ask, do visual cues of being watched increase cooperation or pro-social behavior in humans? I mean, essentially a one-to-one question related to that seed paper that I was talking about. And it gives you some nice feedback. So it says, great question. And I was like, oh, that's interesting. I didn't know about that before. So I asked like a more vague question. I said, what are visual cues? And it said, oh, that's not a good question. More precise questions work better. Try adding specificity or research domain, application context. That was kind of a nice feature. But we've kind of covered that, right? We talked about prompting and the importance of how we communicate and how we use what is this LLM software. And so it's nice to see that that's built in here. And then when you finally do search, you'll see something that looks like this. Now, there's this chat with papers feature, so it has like a summary of all the papers, and you can talk about them. We're not going to talk about that just yet. We're going to talk about that in the context of other tools. But like I said, there's a lot of blur between these things. I'm just trying to keep it structured on sort of how we conduct a literature review. So let's just focus on the 10 sources. It only found 10 papers. This is because I'm just using the free version here. Generally, one of the things that you get with the paid version, at least for these semantic searches and these agentic type of searches, you will get more papers. It will go through more of the literature, which is very valuable if you're doing a lit review. So maybe this is one of the areas where you would consider doing an upgrade for a higher tier. I wouldn't for Elicit specifically because UM has a partnership with something that essentially is the same thing as Elicit. We're going to get to that later. And then you get this nice summary similar to the Google Scholar Labs. And you can add columns so you can extract different pieces of data. And it'll tell you the source of it as well. So we have this thing that says abstract only. So you could extract information directly from the abstract by adding a column. It's like, what is the sample size or something? Okay, but for now, our goal isn't to synthesize the information. We're still just trying to find additional sources. And with the free version of Elicit, we found 10 more sources that we could add. And then we can check for redundancy and make sure that we found unique sources. Okay, very, very quick going through that. Now we've covered 2 tools that do that semantic search, right? We covered Google Scholar Labs and we've covered Elicit. Most of the tools that we talk about from here on really are going to be using the semantic searching rather than the keyword searching. But if you wanted to rely on keyword searching, we've talked about it. So finally, we have the agent-based searching. So a lot of our tools from now on are going to use a lot of this kind of agent-based search, where they're going to combine semantic and keyword searches It's going to then critique its own results. It's going to synthesize the finding, and it's going to take deeper dives into specific questions, right? Ideally, it's finding papers that you wouldn't have found otherwise, because it's not just relying on your initial prompt, it's relying on sort of its own digging through the literature. So we're going to talk about perplexity here. And there are a few options here. We can do a fast search. We can do a deep research, where it's going to do that agent-based thing. And then they have this create files and apps, which I hadn't used before, but was interesting. You can create a file. And then it also has the different sources that it will use. So it has web sources, it has social sources, it has academic sources, so things like bioRxiv. Generally, these programs are using the Semantic Scholar. If anyone has heard of Semantic Scholar, it's another sort of search tool like Google Scholar, and that has an API. So the academic sources are usually coming from there. So I recently used this. So let's do a quick search to figure out what sort of home remedies are good for toddlers that have a cough and the flu. This is very recent. And then, if they do have the cough and flu, can I give them to stop them from being very picky? This is not a super academic thing, but here I have my query. That query is going to be translated into search terms, right? So it's going to do that keyword search that we were sort of developing manually. It then will search through the chosen sources, which was web and social media in this case. Based on those sources, it's going to go through another ChatGPT-like model, those LLMs, and conduct a new search that is based off of what it had found previously. So it's changed from just searching for home remedies to now cough management, fluids, humidity, and the safety. So I never asked about safety. It is sort of inferring that that's going to be an important thing. And then finally, it puts all of these results together into a final report. Yeah, so the way agents work, since we're going to be talking about it a bit, is like a heist movie, right? You have this orchestrator that sort of controls everything that goes on. You have a search agent that is specialized to navigating databases and SQL. Sometimes they're fine-tuned to do that. Sometimes it's just an algorithm that does it. That is going to feed back to the orchestrator, which then goes to some ranking agent. So now you have a bunch of sources based off of that search agent's findings, but you want another specialized model that is able to go through thousands of documents and then rank them in a way that is appropriate. That goes back to the orchestrator, who then gives it to the claim extractor. So now it's going to read through those and find the most important pieces. That could be a separate model, a separate LLM. And all of this goes back to the orchestrator, who then says, okay, we've satisfied, we don't need to do any more queries, which then goes to some sort of synthesizer, which is your getaway car, and then you're done. You get this report all synthesized. Okay, so a more academic example, since our goal here again is to find a list of sources. I'm going to go back to that question in my field, what is the latest developments in phylogenetic comparative analysis? And this time I'm going to do a deep search with Perplexity. And again, this is a website where you will have a set, I think, 3 free queries. So I'm going to search. So I asked this question, what is the latest development? And then it's going to search through the recent papers, reviews, and news. And then you can see, once again, it has those search terms, right? It has those keywords that it developed based off of just my initial query. It goes through, and now it is looking through academic literature only. Or no, I said academic literature in the web. So you can see papers from PNAS, from PubMed, American Naturalist. It has a definition of phylogenetic comparative methods from Wikipedia. So it's using specific sources that I instructed it to. Okay, so it's done that search. It reads through the abstracts of those papers. And then it searches another string, which is based off what it had found. So it found that one of the interesting things was this gene tree discordance thing. That's a recent advance. And now it's going to search deeper into that. And again, it finds more papers. It goes through this through several steps, several iterations of that agentic loop until it finally comes to a big report summary. So the report looks something like this. And one of the key features of this is that all of the findings in the report have been linked to a paper that it believes is in support of whatever it's claiming in the report. Right? So in theory, this is now a cited, this report has citations, it has sources. Now, we talked a little bit about hallucinations. There is no guarantee that the source that it says, the source actually corroborates what it is saying in the claim of the report, right? They can still hallucinate. They can still just say, like, this is what I think this says. There's no guarantee that it does. It's higher accuracy, right? This is starting to use that retrieval augmented generation. This is much, much, much higher accuracy than a ChatGPT general model because it is going to be using these sources directly, but it is also trying to create a full narrative, and sometimes it can get things wrong. The best way to assess it for yourself and sort of see with the error is to use your own work and see how it does, something that you're very familiar with maybe. So the reason that we were using this, though, was still to gather more sources. And you can see that it gathered 95 sources, which is a lot more than we had previously. And so if I click that, I have all of these sources listed. I can look for these links in one of the tabs, and I can export this entire document as a PDF. And so now I have this PDF or a Markdown or a Word doc. And at the very end, it will have links to all of these different papers, direct links. So you can see bioRxiv, academic OUP. And this is going to be useful later. But for the purposes of our lit review, for the stage that we are in, what we really wanted here was not the report, was just the fact that we have more papers for our lit review. So hooray, we have more appropriate papers. One other thing that is worth mentioning is maybe that there was one particular research direction that you did find interesting in the report, and so maybe you want to ask a follow-up. So you can ask a follow-up, and now I just want to know the impact of deep learning on comparative methods. What's sort of going on? How has deep learning been applied to my field? And then I want a comprehensive set of sources that have examined this. So essentially, I want a list of sources rather than an entire report. And so it's going to go through, and this time it's going to do something that's a lot more like an annotated bibliography, right? And I want you to notice that there's a difference in how this report is structured. So I specified a type of structure for the output in this case, and it followed through. There's still, even though these agentic-based models have their own set of steps, how you prompt it still has an impact on the final output. So in this case, I got something that probably would be more useful for finding additional sources. Okay, so now we have this reasonably large set of citations to explore. This would be where you would take your turn, but I'm just going to push through so we can get through everything. Hope that's okay. I assume usually it's okay. Okay, so we have this big set of sources, and now we are going to, we're going to start analyzing these selected sources, and I'm going to start giving more and more warnings about generative AI and the role it plays in academia, I guess, as we go through this. But we'll get there when we get there. So the two subsections for analysis that I'm going to talk about are reading and summarizing the sources. And we've seen pieces of this through other tools that we've used. And then we want to synthesize the findings. Again, those reports are essentially synthesizing the findings. That Google Scholar Labs was a summarization of the sources. But now we're going to talk about them a little bit more explicitly. And I'll talk about a couple of the tools that I trust more for doing these specific things. So, I mean, this is, possibly one of the reasons that we're all here, that we're interested in this type of thing. It's just, if you were to try to summarize all of and synthesize a bunch of literature, the most structured way that you could do it is through something like an annotated bibliography or a literature matrix. You would scan the abstract, the methods, the discussions. You would write a little report that you could then link to a particular paper. It's incredibly time-consuming and rapidly becoming infeasible because there's more and more academic papers being published. So the tool that I want to talk about is possibly one that you've heard. This one seems less likely to be sunset because they've been investing in it. They've released patches on it. It does more and more every week. This is NotebookLM. This is a product from Google. And it is one of those retrieval augmented generation models. So it is going to use the local files that you upload to create that will allow you to chat with your papers that it will cite directly from whatever you have uploaded to it. So this is much more linked to particular papers and PDFs that you give it, rather than sort of abstracts and sort of summaries that it has searched through. Now, NotebookLM does have a search feature now. It used to not. It used to just rely on sort of those local uploads. And there's other systems that can do it. For this first example, I'm just going to talk about a single upload, a single paper, but we'll talk about multiple soon. So the thing that it's going to be doing is you can ask questions specifically about the uploaded comments. You can generate summaries, and it has a bunch of additional features. And one of the biggest values here, I think, is to identify whether this is worth a deep read. So if you upload a single paper and you sort of chat about it and you get a quick summary of it, you can assess whether the paper warrants a deep read. Now, you might be able to do that already from the abstract, but in this case, at least you are able to look at a little bit more in depth because it will go through the entire PDF rather than just sort of making that value judgment at the abstract. So this is NotebookLM. When you hop online, you'll see a bunch of featured notebooks. And what we're going to be doing here is create a new notebook. If you click Create New, you'll see this page, right? So you'll have a place to upload files, to upload links. If you want to use your Google Drive, you can link it there. If you want to copy and paste sources directly, you can do it that way. We'll talk about that searching the web for new sources. That's a new feature, like as of a couple months maybe. So we're just going to be focused here on this file upload. And so let's say I have this one paper that just came out. It's about the importance of of learning natural history for the development of science. Shout out to Andrew Hipp. He's our speaker for EEB seminar and RMC. If you guys want to come watch his talk, it'll be excellent if you're interested in this sort of thing. It's on Thursday and Friday. If you don't, that's okay. The point is I've uploaded this document and I'm going to get this output. So I have here a summary of what the source says. If I click to the Sources tab, or if it's just on the left side, you can see what sources have been uploaded. The reason it has this is because you are going to be able to chat with multiple sources. You're going to be able to integrate a lot of research. For this first step, we're just going to look at one, but in future, in a later part of the tutorial, we'll have multiple sources. A really handy feature of this is the chat ability. And let's just take one of the suggested questions. So the question I'll take here is, why is the revitalization of hands-on natural history education critical for our modern society? And what the NotebookLM is going to do is it's going to examine the question, it's going to think through it, it's going to do that sort of agentic thing, and then it's going to produce an answer to the question based off of my sources. It's not going to, as much as is possible, right? As much as is possible, it's going to answer the question based off of that source. And the reason I say as much as possible is because these LLMs aren't so controllable that its own training data isn't going to come up in the answer. You can try as best you can to make it only answer based off the source, but it has its own training data. It is a predictive model. It's just putting together a string of tokens, and you've added a source to that string of tokens, right? They can still generate things that are not in that source. They can generate things that are just probabilistic outcomes. But as best as they can control it, they're using that source or those set of sources. Now, one of the best features of NotebookLM is that it cites it, but it doesn't just cite it, it cites specific pieces of the text, right? So in some of those other reports, it was citing papers broadly. It's like, this paper said this thing. Here, it is citing a specific sentence or a specific passage within that source data, and it will highlight, this is what I found to support that claim. This is the specific excerpt that I think supports the claim I'm putting in my answer to your query. And that's really useful if you want to see if this excerpt actually supports the claim, right? If you're using it and you want to really make sure that what it's saying is accurate, this is a very useful feature. There's also this Studio tab, and this is one of the things that had it go viral when NotebookLM came out. And we'll talk a little bit more about these different. These are sort of automated generation things, automated sort of chats that you can have. So you could ask it to create a report or you can use one of the sort of pre-made things. One of those is, oh, it's not gonna, is this very creepy AI podcast that it does, which may or may not work. How do I get it? Well, you can look it up and try it yourself, because I don't think it's gonna work for me. Oh, actually, you know why? I bet you. Jesus, oh my God. No. I just want to change the source. Oh my, Jesus. You know what? That's not gonna work. It's okay. It generates a podcast based off of your sources. It's really uncanny valley. It's quite creepy, I find. But it can be engaging, and if you want to do it, you can. It's one of the reasons this went viral. You'll have access to the document if you want to listen to it, or you can just generate your own. Put your own work in there, have it generate a podcast. I feel I've done it, and it makes me uncomfortable. Okay, so I mentioned that we can have multiple sources, so let's explore that a little bit, and let's use this new feature that NotebookLM has, which is fast research and deep research. We've talked about this. The fast research is sort of that, it'll just go very quickly. It's not agent-based. It'll just do a single search and return. The deep research will do that stepwise thing. And so maybe I'm just going to query it, the importance of natural history to the advancement of scientific knowledge, right? That's what I'm interested in. That's what that Andrew Hipp paper inspired me to think about. And so it's going to do an agent-based search. And because this is Google, they're like really good agents. You know, this is Matrix Reloaded Agent Smith, not the Matrix Agent Smith. It's funny if you like the Matrix. And it'll go through and it'll find me a bunch of additional sources. So I find 40 sources over here. These are from the web, mainly. And I have the option to import them into my set of sources. And you can see sort of some of the things that it has found. And it has like really broadened beyond the original paper. And because it's using the web and just answering my query, it has found sources that are talking about how ancient Egypt and Mesopotamia was using natural history for like the roots of science, which is very interesting, and maybe is appropriate for my study, maybe not. You know, I have the option to add sources. I don't have to add all of them. But at the end of the day, we have a bunch of new sources that we have found through Google, and we're able to chat with all of those sources simultaneously and get excerpts and all sorts of information from all of the set of sources. We'll return to NotebookLM in a little bit. But I do want to say something about the data privacy. We've talked about UMGPT, where it's the most secure for your data. I don't recommend uploading unpublished data or manuscripts that are in progress or anything that has sort of personal information, sensitive information. Make sure that you're aligning with copyright. And you know, especially with Google, if the product is free, generally you are the product, right? If the software is free, then they are interested in your information, so take it with a grain of salt. There's no free lunches with anything, let alone tech companies. A couple other things that you might want to consider is that, I found this in my own work, one of the things I did to test NotebookLM was upload a bunch of my own papers and then I queried it about that. And there were slight technical errors. It would make up acronyms where none existed. Now, the acronyms were the right general vibe, but it's like, that was not an acronym that I developed. That was just like one that it had invented based off my own work. So there can be some technical misunderstandings. I recommend actually uploading your own work and seeing, that'll give you a good sense of like, the big picture is usually pretty good, and then like the finer details can sometimes get lost. So the rule that comes out of this is that it supports your reading. It's not going to replace it, right? You're not going to upload a source and get a perfectly accurate description of it. It's just not possible to synthesize that much information to a single summary. But you have the responsibility to go through that. And my point here is that if you just rely on the AI, you're going to get a superficial understanding rather than an in-depth one, which for academics is probably not where we want to be. Okay. So that's reading and summarizing a bunch of sources all at once. Now let's synthesize some findings. Yeah.
Just quickly, is Maisie a RAG? And so this obviously
Yes.
is more than Maisie, but does Maisie do any of this?
Yes, it's retrieval augmented generation. Yeah. So it will like look at your syllabus. I only know the one that's linked to Canvas, where it's able to look at your syllabus and a bunch of things from your class, and then students can query it, and then it'll refer back to your sources.
Well, you can create your own Maisie that would have all your papers in it. It sounds like this, except with a lot less features. I think.
Yeah.
Does anybody else want to-
Yeah, Brad.
Actually ask about that because I went to, I don't know if it was in this series of talks, but I went to a Maisie thing a month or two ago. And they were like, Maisie is terrible at reading PDFs.
Oh, okay.
Don't expect to do this sort of thing in Maisie with PDFs. But it seems, that struck me as really strange.
Yeah, so
I don't know if you
PDF is a really awful way to store text information. I think it's proprietary like formatting, so you can't extract information from PDFs really easily. It's awful. Like we should be using Markdown or some other format for displaying our information. Besides from that, there are a lot of tools that will extract PDF information in a structured way. So you can convert a PDF into a Markdown. It will maybe even just take images of it and then convert that into text. But yeah, there is a step that you have to go from like PDF to like computer readable text that's in a computer friendly format that then an LLM can use. The LLM isn't going to use the PDF directly, it's going to use the text that is extracted from it, the images and the figure captions and all of that. So if it's bad at reading PDFs, it's because that conversion is bad, not because the LLMs themselves are sort of bad at dealing with PDF data. It doesn't make sense, it's just like text, right?
I kind of went into that Maisie workshop thinking that what you were talking about, I was going to be able to do with Maisie, and they're like, oh, no, not really. It needs to be like Word documents and like Excel sheets.
Yeah, I've had success taking data from PDFs. There are a lot of really cool tools, and I mean, like the big tech companies, to train their models, I guarantee they were taking data from PDFs, right? Like they know how to extract data from PDFs. So they're usually pretty good about it. Yeah, and then, yeah.
Just to follow up on that, if you watch like Claude or anything doing extended thinking, if you upload a PDF, it'll often like spin up a little like Python output and extract the text itself. Like so the LLM can't do it, but sometimes it'll have tools to write a little program.
Yeah.
To extract it. The other thing I wanted to note, it's like a limitation here. I think these tools have a limit to the number of papers you can upload. So you can't just take like an entire field and dump it in here and have it extract. It's like 50 papers.
Yeah, that's exactly right, yeah.
Do you have any thoughts about how to organize notebooks given that limitation or get around that? Or like cases you've looked at really focused on just smaller subsets of papers?
Yeah, I've not really hit the upper limit for 50 papers because there is a trade-off between like, that's a lot of context that it has to search. And it has to be able to make connections between all of those papers. If you look at like how the transformer architecture works, it creates this really big matrix between all of the tokens in there, right? So you have this really big matrix and you have really tiny connections between everything. So the more context you have, the harder it is to find pieces that connect it. So I usually have more focused searches. Now the context, like this is an active area of research for them, right? We used to have a limit of 10,000 tokens or so, maybe 1,000 tokens. So that's like, maybe a short paper would fit in the context window. So you weren't really able to chat, but it can read the paper and store that in its memory, let's say. With some of these new Google models, what they've really focused on is expanding that context window. So now the 50 sources, that's like, that could be up 1 million tokens. So there is just like a hard limit on how much information that it can keep in its memory and make the connections with. So my recommendation is just to sort of keep it focused, like that filtering step that we go through when we're finding papers, I would just keep it focused on a smaller subset. Usually 50 papers is a lot, in my opinion. Like that's a lot to try to synthesize. I think it's not gonna be hard, it's not gonna be possible necessarily for, not yet, who knows where this research is going. At the moment, we can't like take all the papers in a field and then, train and then have like augmented generation from that. You could, if you really wanted to do something like that, you could take one of these open source models, take all of the papers, extract the text information, and fine-tune your own model, right? Like rather than ChatGPT, you would have phylogenetic comparative GPT, which is trained on all phylogenetic comparative models and like its responses or some probabilistic distribution of all of the papers in a trade node. That would be like the really extreme way to go about that. But yeah, I think we're sort of 50 papers is a lot of tokens, and that's like really at the boundary of what these models can handle in terms of just the sheer amount of information. So it's not like the number of PDFs that's the limit. It's like how much text is going in it. That's like the real limit for these models. You had a question? Yeah, probably the more friendly the PDF is formatted, probably the more accurate it is. We don't really know how they're extracting the text from the PDF. We don't know that pipeline, but they're pretty good, and you can get pretty good results from some of these extracting tools. So you know, Claude will write a code, but they probably have their own algorithms that they can use to extract it. Okay. So synthesizing findings, I think we'll be okay. So now we're going to compare disparate pieces of information. We're going to compare all of the things that we have found in our previous, all of our sources, and maybe some of the summaries that we've gotten. And we want to find some sort of consensus about what the field has to say about the topic. And I chose the word consensus very specifically because that's the next tool that we're going to be using. The traditional approach maybe is something like a mind map where you link all the concepts from the different papers you've read in depth on the topic and you try to organize your thoughts in some way that answers your question. Maybe you find gaps this way. It's a very difficult thing to synthesize, but it is like one of the most critical pieces of academic work, of this sort of thought work that we do, which is synthesizing massive amounts of information in the field that we're a specialist in. So, I mean, what I'm going to show you, AI can kind of do your literature review, but it should not do your literature review. I chose this because Chris Farley kind of looks like a salesman here, not because of the clip. And so I'm trying not to be a salesman. Okay, so just before I talk about consensus, I wanted to talk a little bit about what this is costing us, even beyond like the monetary and environmental impacts. Like the fundamental problems with this potentially in terms of using it for knowledge work is that we are offloading a lot of the cognitive work, right? We're delegating our thinking to these tools. And synthesis is where we learn a lot. That's where you find these gaps. That's where you sort of learn about the literature. If you're using just AI, you're limiting your understanding of the topic, and you're going to be harder pressed to defend anything that you publish. So, you know, I do suggest generally trying to use it to organize and not maybe necessarily understand. It can be used as like a partner to understand. Like, one of my favorite things to do is to go back and forth on a paper, put little excerpts, but not rely on it for an entire summary, just for different key pieces of the paper that I need help understanding. It can be a really valuable partner, and I think it's worth the hallucination risk just because it's so fast to iterate about concepts I don't understand. The other piece of it, we've talked about this, AI predicts tokens. It's not understanding these concepts, right? It is a string of tokens, and you exchange tokens. You take a turn, the AI takes a turn, you add PDFs, that's another string of tokens that it's using to generate the next string of tokens. And so there's a risk of inaccurate connections, especially as you add more and more context, as conversations get longer. If you recall, like the early days of ChatGPT, when you were at the limit of the context, it started producing gibberish. If you were an early adopter, very quickly conversations ran to the limit, and then it started losing the thread of the conversation. Less of a problem now because we have these massive context windows, but that same thing still exists, right? It's going to maybe hallucinate. One example is that it hallucinates a consensus where there is none because it wants to be helpful. Helpful doesn't mean necessarily accurate or true. It's trying to help you. And if it gives you a helpful answer, then it is satisfied, right? Like I said, hallucinations are constant in these models, right? That's what they do. It's just sometimes the hallucinations are things that we like, and sometimes they're things that we dislike, and that doesn't necessarily mean factual. And then there's training data limitations. There's biases that are introduced there. And then the final piece is that we don't know where the training data comes from. There's copyright issues. We don't know if it's going to quote something verbatim, using it for writing or using it for summarization. We don't know a lot where this information is coming from. So, the best practice, if you're uploading something, it might be better to have things, especially if it's one of these big tech companies, it might be better to use things that are open access, your bioarchive preprint, rather than your unpublished manuscript. And who knows what Google is going to do with that information. Generally, the paid services have much tighter data regulation. So if you pay for a service, it's less likely that it's going to go into training data, but the terms of use are constantly changing. So the free ones, I can say, I looked at the terms of service. The free Google services will use your data for training. It just will. So keep that in mind. Okay, with that sort of out of the way, I want to talk about one of my favorite programs, one that I use most often because UM has a subscription, which is Consensus. I really like it. It aggregates findings from Semantic Scholar, which is that alternative to Google Scholar. So it's going to use that sort of semantic understanding. It has a synthesize features. It's going to review top results for a specific question. It'll provide a snapshot of agreement, which we'll see. It's this consensus meter is what they call it. It highlights conflicting results automatically. It works on open metadata. It avoids these sort of copyright issues. And the best thing about it, in my opinion, is that it uses the library libkey. So it has access to whatever the University of Michigan library has access to. So this is one of the tools that can use full text if the Michigan library has access. Yeah.
Hi, I'm a librarian.
Yeah.
And yes, we have this tool right now, but I will tell you, it's a trial.
Oh, okay.
So we didn't buy it.
Ah,
License it.
I see.
That's fine, and actually, I would love your feedback so I can tell the person running the trial, they should just extend it. It was gonna expire.
Ah, okay. Oh my goodness.
We have it for quite a while.
Okay.
We have it for quite a while, so if anybody does use this tool, my name is Sarah Barbaro, I'm an engineering librarian. You could like Google the UM library and just submit feedback to like ask a librarian about this tool.
Yeah, so everyone should go use it and try it. I really like
But
it.
if you like it, I'm gonna send you an email after.
Yeah,
if you
please
want to
do.
get your feedback,
Yeah.
because we often trial things in here.
Yeah. Well, so one of the things I like about Consensus too is that they respect that robot.txt that is in a lot of websites where it's like, please don't scrape our data. Something like Perplexity doesn't. They will be like, who cares? I'm going to scrape it anyway. So Consensus, as far as I know, does respect that. Anyway, yeah, so enjoy the free trial while you can. Use it, see if it's useful, and then provide some feedback. I really like it. And let's go through some of the features and maybe well, no, I'm not going to sell you on it. I refuse to be a salesman. Okay, so we have the same options that we've been seeing a lot. We have the quick feature, the pro search, the deep search, and you can see that you have the pro and the deep are scholar agents with the variation being how many papers it's going to go through, 20 papers or 50 papers. With a fast research, which is 10 papers. We have this sources set, and so Consensus specifically uses academic sources. So you won't have the web or the social media options, but you can also do you can do medical journals specifically. You can upload your own papers. So if you want some sort of retrieval augmented generation style responses, you can upload papers specifically. You have a bunch of filtering. So you have journal ranking. So this is like the impact factor of the journals. If you want them to have at least one citation for the paper, you can filter based off methodology, sample size. You can filter based off of the year, standard sort of filtering options, and then some sort of more advanced ones. So I sort of skimmed over it, but filtering on methodology is really interesting because you can find papers that have at least like a sample size of 10. And the way that the model assesses that, it'll search the paper, it'll go into the open, into the text, if Michigan Library has access to it, it'll go into the text and find the sample size. If that meets your criteria, it includes it in the report. So it's really interesting in that regard. Here is the trial subscription from the University of Michigan. And this is the library key that you can provide. So you can get full text and links to papers. So there's a few things that you can ask it to do. It works based off prompts again. So it's not going to have a specific tool that drafts an outline. It's going to create a prompt that says draft an outline. So there's a lot of flexibility in what you want as output, depending specifically on the prompt. So for this one, I did one that is for the consensus meter, and it does static stretching before exercise, prevent acute muscle injury. We did a pro search, and so it goes through and it reads some results. So it finds what kind of question is that. It'll go through the this academic literature. In this case, it found 20 sources, and the main takeaway from this, like again, the crown jewel of this program is this consensus meter, right? So it looks through, it finds the studies that said, yes, static stretching does prevent injury. It says, no, these studies said that it did not prevent injury. And then there's this possibly preventing injury. And then based off all that information, it has its own answer, which says, no, static stretching alone before exercise does not reliably prevent acute muscle injury. It found 7 studies in total that it is using to inform that assessment. If you click all details, now that, should you be relying on that as your answer? Probably not, but it's a nice feature. But if you go to the details of these papers, you can see a breakdown of each of them. And so here we have our results. So it summarizes the papers that we're saying it supported it. So the yeses are systematic reviews and meta-analysis, as well as a narrative review that found that it reduces muscle injury risk. The no's were 2 small quasi-experimental studies with low sample size and no journal ranking. So it's this agent-based thing where it has agents that assess its own assessments and gives you the consensus. We have the recency, so what's the average age of each paper? The methods, tier 1 and tier 2 studies, it's really randomized control trials, meta-analyses, systematic reviews are tier 1 type studies. If you click it, it'll tell you what it thinks tier 1 studies are. So this is sort of like an automatic meta-analysis in a way. The journals, so what's the average rank of a journal? Q1 being the top tier journal, highest impacts. And then we have citations. So how many times have the papers that went into those results been cited? So there's been no citations for the no results. The other thing, if you scroll down a little bit, you get this report. And in the report, you can find the sources as well. So each little each sentence will be linked to a paper. And you can see that it was able to access the full text for this. If you go to the details of this paper, you can get a snapshot of it. So here we have a summary at the very top. So this short duration stretching, what the methods of the paper were. So it was a comprehensive review, the outcomes, effects of static stretching on strength and power, short duration stretching, and then the results. And then you're able to see that it extracted 3 of 7 attributes that it tries to find. So it looks for the methods, the outcomes, the results, and population, sample size, duration, and location are things that it's trying to extract. So these are very meta-analytic type topics that it's looking for. Scroll down even further, and you can find, again, a little summary of everything, the outcome, the context, the citations, color-coded by whether the study supported or didn't. If we go down to the very, very bottom, we get our results. This is the list of papers. Another interesting thing that you can pull from this is a table of the papers where you get the paper, what it found, the population, the methods, the results. You get a list of different things that are summaries from the papers. And then finally, you can download the citations as something that can be imported friendly to EndNote, Zotero, Mendeley, whatever your reference manager is. I'll just push through. I want to return to NotebookLM because we didn't really talk about it in terms of multiple sources. So what I'm going to do, because we haven't used it for synthesizing information just yet, I'm going to take that PDF of all of those links that I found previously, and I'm going to paste it in ChatGPT just to remove the numbering, and then I can go to the links, and then I'm going to paste all of those links into NotebookLM. So there we go. There's my, how many sources? 48 sources that I'm going to use for learning about deep learning in phylogenetic comparative methods. And I just want to highlight a few of the things that can be done in the studio, which I think are really interesting. So this is all open source stuff because there's just a set of links, so whatever Google can access. It's not using the library key. So a little bit less formal. But it can create reports, briefing docs, study guides. And what I recommend doing for just exploring, because it takes time for all of this stuff to process, is just look through some of the featured notebooks and sort of get a sense of what the capabilities are. So just to highlight, this is the complete works. This is one of the featured notebooks. And they just uploaded the complete works of William Shakespeare. It's a cool idea. And you can click through and see some of the things that it generated. So it generated an image based off the complete works, and it's called the Wheel of Misfortune. This is what it generated based off those 4 sources. Obviously, this is AI generated. I haven't thought about William Shakespeare since like grade 10, so I don't know if this, hope maybe there's someone in Lit that could tell me if this is interesting or not. I do not know. But it's an image based off a bunch of sources, so it's using all of those pieces. You can get a PowerPoint, so here's the burden of kinship. I did think about trying to make a PowerPoint, like a little mini PowerPoint within this PowerPoint to see how it does if I collate a bunch of sources about GenAI and Lit. I didn't do that in the end. But here is a PowerPoint based off of the entire works of William Shakespeare, and it ends with "Uneasy lies the head that wears the crown." It seems accurate to me. Every Shakespeare play that has had a king that I know of, that seems reasonable. You can get study guides from it. So, it can if you want to use it sort of pedagogically, it might be a useful way. If you upload a bunch of textbooks or a couple textbooks, you can look through and see if those study guides, it might be a good starting point or not. Also creates these mind maps, which are kind of interesting. So you can look at the themes and characters, love and relationships, lust and desire, and here's all of the sources here's all the potential interesting pieces of lust and desire that link to it. It's a very comprehensive mind map. So the point is that there's lots of pre-made tools that allow you to chat with all the sources directly. And so just finally, just to touch on this, we're almost done, I promise. Just to touch on writing text and citing sources, sort of 2 steps that I think about it: drafting and revising with AI, and editing and polishing with citation safety. I'll explain this reference. This is from Goodfellas, and it's meant to be like when you're in too deep. Like if you're using AI to write your papers, you might be in too deep. Anyway, so drafting and revising with AI, write the first draft yourself and ensure cognitive engagement. And I see sort of 2 ways that you could use AI very effectively. In my own experience, there's obviously a lot more to do it. I'm not trying to say this is exhaustive, especially if it's only 2. So you can use AI to help you generate outlines, or one thing that's really fun is trying to do a reverse outline where you give it a piece of text and then you ask it to structure your argument and just see if your argument is cohesive based off of what you put in, which leads really nicely into this sort of critical reviewer idea. So you can ask it, don't ask it to write this section, but here's my argument. What problems do you see with it? What are the counter arguments? So you can use it as a critic or a reviewer. You can also use it for editing and citation, editing and polishing. So AI is really good at fixing grammar. I know if English is your second language and you're trying to write academic papers in English, it's a really useful tool for sort of leveling the playing field. If you want to find active voice or passive voice, it's not a citation management tool, right? Like don't have AI write your citations, but if you're worried about formatting, say that this is my particular formatting style, here's my references, are there anything not following that? Even with Zotero and reference managers, there still can be errors. A couple warnings is that AI, we talked about this, does hallucinates citations all the time, and they will look very reasonable. So don't have it create a bibliography for you. It won't be able to. Some of the papers might be real, they're like very popular papers it can find and reference exactly, but it'll make things up that sound very, very plausible. And so always verify what it tells you. Okay, so that's it for the phases of literature review. And just to conclude, let's talk about sort of how you choose your AI tool as like our way to summarize everything that we've talked about. So the first thing to do is consider what phase exactly you are in. If you are in phase 1, the brainstorming phase, maybe use a general AI just to sort of bounce ideas off of and chat with. If you're searching for papers, use one of those academic AIs, maybe Elicit, Research Rabbit, Perplexity, or Consensus. If you're trying to analyze papers, do something where you can upload PDFs, as long as you're following copyright and personal information protocols. So use local AI inputs, and if you're writing, maybe as a sparring partner or an editor, you can use a GenAI. What types of sources are you using? So if you're using open web sources, these general LLMs are probably sufficient. They can now search the web anyway. If you want academic, you have to use something that is more specifically linked to an academic database, which is something like Elicit or Consensus. If you're using PDFs that you have, something like NotebookLM is usually going to be the best. You can upload papers to Consensus as well, but NotebookLM has the nicest features for it. What costs are involved? I recommend just starting with free tiers and then seeing where you hit a wall. If you want to invest in some of these tools or pay for some of these tools, you can, but explore the free options first. You'll get a pretty high quality product because they want you to pay in, right? They're not going to limit your quality, they're going to limit your usage, generally. Do you need deep reasoning? You know, how deep do you need this thought about? It's, you know, deep reasoning is slower and more costly, but it finds maybe more obscure papers. We've talked about most of this. And then, do you want to upload sources to the tool? Oh, yeah, I guess this is sort of redundant. But yeah, if you have open access and public, you can use these local models. But if you have something that's sensitive or unpublished, UMGPT might be an option. Depends on how sensitive your data is. So my conclusion is not super, positive. I want you to pause and think about it before you really dive deep into this. AI speeds up the mechanics of research so you can find and sort and summarize things, but it doesn't replace expert judgment. There's been studies which show that, and this aligns with my personal experience, if you have an expert doing a review, they will find like the critical pieces of information. It'll be very like a fine pointed spear. It is like really refined and exact. AI is really good at breadth. They find a lot of papers, and I have found like there are papers that AI has suggested to me in some of these searches that it's like I would never have come across this. This is like very different than what the literature that I know. So it lets you get out of your comfort zone maybe more than an expert reviewer. But if you want like a really fine-tuned review, AI isn't quite capable of doing that. Keep in mind that these are probabilistic and not factual. They are always hallucinating. We call a hallucination just an output that we don't like. So make sure that you verify every single thing that you see. And this sort of relies on, this connects to this last point. So over-reliance on AI can degrade your critical thinking skills, and ultimately everything that you put out is your responsibility. You have to source things. You have to make sure that it is accurate. So don't outsource your understanding and thinking about academia to these models. So use these tools to support your process, not to do it for you. These are all the links for the tools I've talked about today, and otherwise, thank you for your attention. Any concluding questions or thoughts before we go? Yeah. Kelly will know? I don't know. Yeah. Do we have the research scientists here? Maybe not. Oh, Nathan's in the back. Nathan, do you know where they'll be uploaded?
That's the Midas YouTube channel.
YouTube channel. Yeah. Midas YouTube channel. Yeah.
I may be slightly obsessed with hallucination of references. I was going to ask again,
Yeah.
why can't you ask one of the GPTs to look at the references and make sure they're real? It doesn't work. I think I've tried that.
Yeah, so it doesn't have like a database of information that it pulls from, right? It's strange because it does memorize facts sometimes, like it does have this memorization capability, but it's not a perfect one-to-one understanding of the literature, right? So it doesn't have like a database that it is able to pull from, that it is able to accurately assess it, I don't know how to explain it.
I mean, it seems like if the references exist and they're real,
Yeah.
and it can find them, but then it also makes them up. How can it not figure out?
What do you mean by? No, that's fine. Nathan, you have something?
The easiest way to think about it is it's not it has them stored as real references, but it's generating text at the same time.
Well, so like the raw neural net wouldn't be able to check the fact necessarily, right? Because of the stochasticity of it, because it doesn't have a database of these things that it can reference. However, it can like develop a tool that and it can code up a tool that would then go out and check the source. It can't do it directly though. It's not a database. It's just not able to do that. It's well outside the capabilities. I don't think there's going to be a case where it ever is able to do that because it cannot. If it just was a perfect memorization of everything, it'd just be a big database of all the internet. It's not that. It is storing the information in those embeddings that then are like subsequent representations. If something comes up enough, it does have like a pure memorization, which is why the question is tricky. Like it can memorize things one-to-one almost, but it doesn't memorize everything one-to-one, and it has to rely on sort of a compression feature. It would be a subsequent tool, like one of those agent-based tools can check references. And so those references are usually real because they're coming from scholarly databases that have those exact references. ChatGPT doesn't have that stored. It's like that. It's just not how the models work. Yeah. Mm-hmm.
So if I like provide the source to ChatGPT and specifically say look for information only through the sources, is it like going to act kind of like agent?
No. I mean, unless it could, if it has access to tools that can do that. So if it is able to put those sources into like some tool that then searches the web and that web is scraped and uses it. But in terms of raw input, you will be prompting it to answer it will answer something that it sounds really reasonable. So it knows the sources in a sense, like it has like this vague idea of what all the sources mean. It can look at those words, and you are essentially, what's the word? You are sort of setting it up such that it is going to answer something that sounds really reasonable for those sources. And it might directly quote the sources. It has certain things memorized, but it is not directly pulling from those sources at all. Like it doesn't have that information stored. It has like a general idea of the kinds of things that would be said if it was pulling from those sources, which is why it's going to sound reasonable, but it will not be quoting them. That's where the retrieval augmented generation is really important, because it's like, it's not in the context. Those sources are not in the context. Only the exact reference that you put is in the context. The retrieval augmented generation is useful because now it's like it has that PDF, it has the text associated with the sources, it has the context. So now it can quote things directly from that context. Yes, exactly. Yeah. Yeah.
If you had to choose one of the applications to use for tutoring, just one of them,
Mm-hmm.
what would you choose?
I think my favorite is finding papers this way and sort of the quick summaries that you get from them. For synthesizing information, I don't use it as often, but if I want like just a quick look at what's in the literature, I'll just search some topic that I'm kind of interested in. I'll find a bunch of papers, and then I can look through those papers individually. Sometimes I find it works better than just like my Google Scholar search. So this would be like Consensus or Perplexity are both pretty good at searching academic sources and finding papers that I would have otherwise missed. That's my favorite use of it, which is not the most, it's far from the most exciting use of it, but it's the one that I trust like fully because it's just a link to a paper, and I'll read the summary to see if it's like kind of interesting, but if I'll do the assessment myself. But it's a matter of trust, right? We're sort of building trust with these models as they get more accurate. I might move my interest down the pipeline. It's like these summaries are the most useful thing, and maybe these connections are the most useful thing. No, it's an interesting question. Cool. If there's nothing else, thank you all for your time. Drive safe.